In this video, we are starting our section on parabolas and symmetry. So our goals are to sketch the graphs of lines as a review, and parabolas, which will be our new topic. How do we find the vertex of a parabola? By completing the square and testing graphs for symmetry. In this video, we're going to do a quick warm-up example where we sketch a line. So let's get right into it. So I want to sketch the graphs, label all relevant points like intercepts. So in part A, I have this equation here. So what I notice is, well, I can isolate the y by dividing both sides by 4. And if I do that, I'll get y on the left equals 3x minus 12. That whole thing divided by 4 on the right. And then I can split up this fraction into two pieces, where the first piece will be, I'll get my 3x over 4, and then I'll get minus 12 over 4. And then, well, I could rewrite this a little bit as 3 over 4 in front, multiplying the x, and then minus 12 over 4 just becomes 3. So when I think about this graph now, I can see what the slope is, and I can see what the y-intercept is. So my slope and my y-intercept. So my y-intercept is negative 3. So I'm going to draw this with the y-intercept at negative 3. Okay, I'll label that as 0, negative 3. And then the slope is 3 over 4. So this, I'm going to rise up 3 units and then go to the right 4 units. So that's a positive slope. So that's going to be something like this. Something like this. And then just to be thorough, let's find the x-intercept as well. So for my x-intercept, just because it did ask me to find the intercepts, for the x-intercept, I got to set y equal to 0. So set y equal to 0. So I'm going to plug 0 in for y. So I'll get 0 equals, I'm plugging in 0 for this y, equals my 3 over 4x, 3 over 4x, and then minus 3. Now I can try to isolate the x by first I'll add the 3 over, and I'll get 3 on the left equals 3 over 4 times x. And now to get rid of that 3 over 4, let's multiply both sides by 4 over 3 by the reciprocal. So by 4 over 3. So on the right side, I'll just be left with x. And on the left side, well, I can cancel this 3 on the top with that one on the bottom to be left with a couple of 1s. So overall, I just get x equals 4. So my x-intercept, I'll go ahead and label it, is at 4, 0. All right, nice. So what about now this example in B? I'm going to call this function f of x. And I have 1/4 times the absolute value of 3x minus 12. So, the first thing that I notice is this looks kind of similar to the function that I had here, 3x minus 12. There's this kind of divided by 4 going on. In fact, well, 1 over 4 is the same thing as if I were to write absolute value of 1 over 4. And if I have the absolute value of something times the absolute value of something, I get to write that as one absolute value. And then multiply those two terms together. So multiply that 1/4 and that 3x minus 12 together. So I get 1/4 times 3x minus 12. But that's the exact same function that I have here. I'm just absolute valuing the whole thing. So what does putting an absolute value around a function, what does that do to the graph? So the absolute value makes negative y values become positive. So, okay, I'm going to go ahead and draw some axes. So it's going to take the part of the graph that I had with the negative y values here, and it's going to turn those positive. And if it turns those positive, it's going to flip it up across the x-axis. So we are going to have to reflect. So reflect the part that's below the x-axis across the x-axis. So if I do take this part that's below and reflect it up across, well, that part starts looking like this. So at my x-intercept, which is 0, 4, it kind of goes up like that. And now this y-intercept is hitting at 0, 3 rather than negative 3. And then, well, the y values that were already positive, well, the absolute value just takes those and it just keeps them the same. So those will look exactly as they are. And that's my graph. So in general, when I take the absolute value of some function that I already know the graph of, you keep the parts that have positive y values, and the parts that have negative y values, we erase them, and then they get reflected up across the x-axis.